All right, so in today's lesson we're going to be looking at the symmetry of the unit circle, and this is quite a nice little lesson. It's very it alleviates a lot of our stress around the unit circle because we only have to work out or remember one set of values and everything else is just symmetrical. So let's dive right in. All right, so to start with, you might notice that the x and y axes on the unit circle neatly divide the circle up into 4 parts, and they are known as quadrants. All right, so this is quadrant 1, 2, 3, and 4. All right, now you might notice that it goes anti-clockwise. I've explained why that happens because this is in conjunction with the compass. This is north, east, south, and west, and the sun goes from east around to west. So that's why we measure angles anti-clockwise. All right, so we've got the 4 quadrants. We've got 1, 2, 3, 4 anti-clockwise. All right. Now, next thing is you might remember that we're mapping a point on the circumference of the circle. The circle has a radius of 1, being the unit circle, and then the point's location is given by sine and cosine. All right. Now, you can see then that sine is the y value of the point and cosine is the x value of the point. So the point's location, all right, can be written like this: cos theta, sine theta, whatever this angle in here is. All right. So if I need to know the location of the point, all I need to know is the angle, and I can use the cosine to calculate the x value and the sine to calculate the y value, and there is my point's location. Now, from 14a, you might remember that, I think it was 14a, sorry, it might have been 14b. You might remember, yeah, it was 14b. You might remember that there are certain angles that have the same values as each other. All right. So if I look at this one here, I'll call this point P1 to make it a different point. Okay. And you might notice that this angle in here is the same size as this angle here. All right. However, it's on the other side of the y-axis. So given that this direction of the y-axis is negative x, we would expect this point's location to be the opposite of the cos, negative x, but the same y value. So it's the same height. So I can illustrate that by showing you there's a horizontal line across there. They're at the same height, all right, which means the y values are the same, but the x value has switched from positive to negative. All right, that's the only change. And that's what happens in quadrant 2 for all values or for all points. All right. All that happens is the cosine switches from a positive x to a negative x. All right. Now, moving down into quadrant 3, if I put a point down here, it might look like this. There's point P2. All right. You might notice there that the y value is now also negative. So the point's location is going to be a negative cos value and a negative sine value. I'll make that a little bit more clear, sorry. All right, a negative cos value and a negative sine value there. All right, because the point is below the x-axis and to the left of the y-axis. All right, so continuing around into quadrant 4, we've got our point on the circle. We'll call it P3. You might notice that the y value is still below the x-axis, so therefore the sine is going to be negative, but the cos has flipped back to the positive x values, so that's just cos theta. All right, so the point's location is positive x, negative y. So this sort of symmetry leads us to a neat little acronym that we can use to remember which values are positive in each quadrant. And it looks like this. You can just say A, S, T, C, and this stands for all, this stands for sine, this stands for tan, and this stands for cosine. And what this means is in quadrant 1, all the ratios are positive. In quadrant 2, only sine is positive. In quadrant 3, only tan is positive. And in quadrant 4, only cos is positive. All right. In each of those quadrants, the unlisted ratios are automatically negative. And if you look at this, we see that cos is positive, but sine is negative. And because tan relies on a combination of sine and cos, if one of them is negative, then tan must be negative also. So that makes sense. This acronym only lists the ratio that is positive in that quadrant. All right, so ASTC for quadrants 1, 2, 3, and 4. All right, now the next part of symmetry that we're going to look at, I've hinted at in the diagram so far, but I haven't explicitly explained, is this angle size in here. All right, so if this angle in quadrant 1 is called theta, in quadrant 2, it's not quite theta because we always measure from 0 around to there. So this angle is going to be a little bit bigger, or a different way of describing it. Now I've referenced this as theta measuring backwards from the x-axis, but that's not how we measure angles. So we need another reference point. All right, so we could call this angle pi, because pi is half a circle, minus theta. All right, so it says we go to pi and subtract whatever the angle is. So if this angle here was 45 degrees, the angle would be pi minus 45 degrees, and so on. And we would read that and know that we start at pi and subtract, go right, 45 degrees. All right, now, if that is the case, pi minus theta, given that this angle in here is the same size as that one, that must mean that sine and cos are the same values. The only thing that changes is whether or not they're positive or negative. All right, because we're using the same angle. It's this theta from quadrant 1. All right, so this symmetry means that we only have to memorize exact values for angles found in quadrant 1. All of the other quadrants use the same exact values, but different combinations of negatives and positive, depending on which quadrant they're found in. All right, so in quadrant 2, the angles will be written in the form pi minus theta, indicating we should start at pi and go backwards however many degrees or radians. In quadrant 3, the angles will be written in the form pi plus theta. If in quadrant 2 we went backwards that way, then obviously in quadrant 3 we'd go forwards that way. All right. In quadrant 4, the reference point reverts back to the x-axis, which is 0 or 2 pi, and we'd start at 2 pi and go backwards. So that angle there is 2 pi minus theta. And then the initial angle is always theta. All right. So you will see angles written in those forms. What you need to do is identify what this minus or plus is, and that will tell you the theta. Then you would refer back to your exact values from quadrant 1, and then you would apply the correct negative or positive combination to find the sine and cosine for the given angle. All right, and I will share with you, we'll do an example of it. Okay, so here is a few examples. All right, so few examples. It says if sine x equals 0.6, find the value of sine pi minus x. So a quick sketch of the unit circle shows us that pi minus x is this angle here. All right, I know the sine of x is already 0.6, and because this x is the same as that x, I know that the sine value stays the same. What changes in quadrant 2 is that the sine value is positive and the cos value becomes negative. So because the sine value stays positive, I know that the sine of pi on pi minus pi minus x is also the same as in quadrant 1, so it stays as 0.6. All right, because the sine value is this vertical height, and you can see that it's above the x-axis, which is a positive y value. All right, next one is sine of pi plus x, which you can remember is pi, and then moving that way into quadrant 3. You'll notice now that the quadrant being quadrant 3 is a negative y value. So because that angle is the same as the initial angle, that means that the only thing that changes is whether it's positive or negative, and being in quadrant 3, it becomes a negative, so it's minus 0.6. All right, the third one, 2 pi minus, so I flip back around to the x-axis on the right-hand side and I subtract whatever the angle is, so that creates this line here. Now I know that in quadrant 4, the y values are still negative, being below the x-axis, so that means that the sine becomes a negative 0.6. And then the last one is minus x. All right, and this is written a little bit differently. So that means we start from 0, and instead of going that way, we now go this way. So it's actually the same as the angle I just drew, except I've started from 0 and not 2 pi. So because I have to go backwards, that means that the angle is still in quadrant 4, which means that it's still negative. All right, so the key learning here is that using a given angle, sine and cosine in the different quadrants don't change. All that changes is whether they're negative or positive, which is a direct relation back to the Cartesian plane that we're all familiar with from all the way through year 8 and onwards. All right, so all you have to do is match up whether or not the angle is in quadrant 1, 2, 3, or 4, calculate what the sine or cosine is, and then put the relevant negative sign in front of it if required. All right, to finish off, we can do the same thing using degrees instead of radians. You might have noticed that in the previous example I used pi as my reference points, which indicates we're looking at radians instead of degrees. In these ones, you notice that it's all 180s or 360s, which means we're talking about degrees. You can also see that the degree symbol has been used. Over here, you notice there was no symbol used, which is another indicator that we're looking at radians. So cos of this angle is 0.8. So now I want to know 180 minus the same angle. So I draw my unit circle. I have 180 out here on the left. I'm going to move backwards by however many degrees x is to create this angle here. I need to know the cos. So the cos in quadrant 2, I might remember, is negative. Other than that, it doesn't change, so it's going to be negative 0.8. And it's negative because it's on the left-hand side of the origin here, and that's negative x values. All right, 180 plus x is going the opposite direction like that. Nothing has changed in terms of x values, so I notice that it's still a negative cos. All right, 360 minus x is here going backwards that way. So there's my angle, there's the point. And we notice that this side of the x-axis is positive, so therefore the cos stays as a positive 0.8. And then the last one is minus x, so it's from 0 degrees backwards, because backwards is indicated by a negative angle. And so that's the same side of the x-axis as previously, so it's again a positive 0.8. All right, so to recap, there are 4 quadrants of the unit circle, starting from top right going around anti-clockwise. All that differs between them is that the cos and the sine change from positive to negative and back again. All right, and that indicates whether or not the tan will be positive and negative also. Okay, to calculate sines and cosines of various angles, all you have to do is identify which quadrant they fall in, then apply the relevant sign to the value.